Welcome to the safety demonstration brought to you by Southern Marin Electric Cooperative. I'm Brian Lazarchik, Safety Director for SMECO. Joining me is Ron Rennick, our Senior Safety Training and Testing Manager. Along with us are our qualified linemen from our Central Region, Jeremy Green and Doug Hancock. Working at SMECO, you actually have to go through a 4-year accredited program to understand the safe work practices. That's why our qualified linemen can make these energized connections, but we're asking that you have a general hands-off policy. During that 4-year accredited program, it's actually 2 years before they can make any sort of energized connections. They learn the electrical theories necessary to perform the work safely. They have specific personal protective equipment that they wear, starting with a hard hat. That hard hat has an insolution value up to 20,000 volts. That's if they're working in a bucket and they make their head bounces off of an overhead conductor. It will actually protect them up to 20,000 volts. Moving down, you'll see that very thick rubber insulating material, the rubber gloves and sleeves. That rubber gloves and sleeves has an insulating value of up to 17,000 volts. Every 55 days at our company, we collect every person's rubber goods materials, ship it out to an outside laboratory, and have them tested to 20,000 volts. That way we can ensure that its protection is available for our qualified linemen. Every morning, they do a blow-up test to make sure that there's not the slightest pinhole in that rubber glove or sleeve material, because that slightest pinhole can have actually electricity track through it, which would be catastrophe for our qualified linemen, as they use that as their last means of defense. Moving through their uniforms, it's actually a fire-retardant material. That material is designed to automatically self-extinguish if they were ever in that intense heat in an arc flash environment. What that means is, as soon as it ignites, it's going to automatically go out. If you are wearing the clothing that you're probably wearing now, synthetic fibers, that material will actually burn and melt into your skin. That's why they say sometimes you're better off naked than wearing any clothing whatsoever in that arc flash environment. Lastly, steel-toe boots. Their steel-toe boots aren't just your normal construction steel-toe boots. They have a step potential value of up to 20,000 volts. Step potential is an electric phenomenon in which ripples of electricity actually ripple from the center out, much like ripples in a pond. So if you were to put 1 foot on one ripple, 1 foot on another ripple, you would actually bridge that gap between those different potentials. Almost the same as going up and grabbing an overhead conductor. The equipment that they use, Jeremy's actually holding a hot stick right now. That is a fiberglass resin material that we test every 6 months to 100,000 volts per linear foot. That way we can ensure that if we're using this equipment, we can ensure that they're isolated from any energized connections. And now Ron Rennick's going to take over and go over the rest of the demonstration trailer.
We've used this for training of all of our first responders, all of our other local utilities, such as phone and cable TV, and our tree trimming service. The whole point in this demo trailer is to show the hazards of dealing with electricity. So what I'm going to ask you to do is use your imagination. With this piece of wire I'm holding right now, imagine this is just a stick or a piece of aluminum siding that was blown off during a major event, tree trunk, anything you can think of that can make contact with our energized circuit. With that, I'm going to have Jeremy show you what happens when you cross into our electric. The loud explosion you heard was what is called a fuse cutout door. It's a one-time event. What you need to do is call your local utility and they will run a service truck out there. And what you need to do is always call your electric company if your power is out, because you may be the only one out. The next step these gentlemen do when they arrive out there at the job site is they will come by and take a look at that blown fuse. They will remove it. They will install a caution tag, which tells everybody else that this line is being worked on to leave it alone. Either go down and help them, but never re-energize. The other procedure they do, put a ground on both sides of the area they're working in. This ground is installed for 2 reasons. One for personal protective from any incidental re-energizing of this line. The other is our most concern is backfeed from generators.
All right, Jeremy and Doug installed a protective grounds on both sides. One in case that line gets re-energized from the source end, but also generators in case it gets backfeed. Backfeed typically happens when somebody hooks up a generator at their house improperly. It can go through their meter, up through the transformer, and backfeed on our lines at the same primary 7,200 volts. So it's very important our guys put the grounds on both sides. Once they have the grounds on both sides, they'll remove the obstruction, and then they'll remove their grounds and move back to the tag, removing that tag out system. At this point, they could go back and energize that circuit, and their lights are back on at your house. Okay, what you saw there was a single fuse cutout. Now we're going to talk about a reclosure. A reclosure is very important for you as a customer because it helps increase your reliability. When a tree bumps across the line and you saw that explosion, that was that fuse cutout, with a reclosure, your lights will momentarily go off but automatically come right back on. They'll do that up to a set point of 3 possibly different times. So what Jeremy is going to do right now is take a protective ground, turn on the recloser into reclosing mode, and bump the ground into the overhead conductor and show you that we don't necessarily have to send a truck out when a recloser is in operation. Notice the lights are off now. Recloser is on. He's going to take that protective ground and bump it into the phase, the same you saw with the explosion. Notice the light goes on, goes off. Goes on, goes off. This is very critical that you know this, because if you're in an environment where you see down power lines and you think, oh, that's okay, I just saw something happen, that has to be absolutely de-energized. And it may be de-energized at that moment, but at any single moment with a recloser, it might come right back on and energize. Very critical you stay away from any enclosures or down power lines or electrical equipment altogether. Okay, everything you've seen in this demonstration so far was on a simple 120 volts. We're actually going to switch our trailer over to our nominal operating values you see on the distribution lines running through your neighborhoods of 7,200 volts. What you're going to see now is the same exact thing that would happen if you were to do this at home. The things we're asking Doug and Jeremy to do go against every bit of their nature and training that they have picked up. It's very unfamiliar for them, and it's something that they don't want to do. But we're doing this to educate you on why you have to stay away from our energized lines and equipment. First thing we're going to do is, you might have learned long ago, there's things called conductors, there's things called insulators. Well, what you learned probably in elementary school was a conductor or an insulator at typical 110 voltage, household voltage. We're going to talk about what a conductor and insulator is at 7,200 volts, which you probably would run into if you were going to deal with this equipment after, say, a major storm or any outage event. So first thing they're going to do is they're going to remove this door, and we're going to stick some materials to bridge that gut out. First thing we're going to talk about is wood. Typical stick, we just cut it off this morning. This stick, I remember when I went through elementary school, they always told us wood is an insulator. You could take wood, put it in an electric circuit, it would not complete that circuit. But unfortunately, this myth at 7,200 volts could significantly harm or even kill you. That's why we're asking you to not use wood or any sort of object to try to touch our overhead lines or equipment. Now you see he bridges this, look at the light comes on. That 7,200 volts is easily flowing through that wood. So there, wood is a conductor at 7,200 volts. Next thing we're going to talk about is this service wire. You may see this running from an overhead transformer, like designated on our trailer right there, to your house. It has this really black tar material, jacket material on the outside, and you will think, oh, well, that's an insulator. It's got to be an insulator. It's protecting that wire in case somebody ever went up and grabbed it. You might be doing maintenance on your house, painting and siding, and you're coming very close to this material with that false sense of security that it has an insulation value. Doug's going to show you what would happen if you made direct contact. feeds right through that material, light comes on at the house. That black tar material is actually to protect the wire itself. It has no protection value for you. Stay away from any overhead lines, even if you think they're secondary voltages. Next thing we're going to talk about is a kite string. I just pulled it out of water, so I'll give you that. But the reason we put it in water is because it would just burn up if we weren't have it wet and damp. But also, when you have kids and you're flying kites, typically, unless you're a professional, the kite string and the kite are lying on the ground, dragging through the mud, the dirt, and the water. And that's how you'll find it. So all of them debris can actually have electricity track down the kite string. Remember from elementary science class as well, electricity always just wants to find the easiest path to ground. So if you become that easiest path to ground, unfortunately you're going to feel it. If you have little kids or you're an adult and you like to fly kites, please look up first. Make sure there are no overhead power lines. Doug's going to demonstrate whether or not this kite string will actually feed electricity through it. Alright, it doesn't even sizzle. So unfortunately, if you were flying kites, that kite went into an overhead conductor, came down that kite string, go through your body, through your feet, into the ground. You are the easiest path to ground. Another phenomenon we would like to talk about is you may drive down the streets and you'll see a bird just perched on top of an overhead wire. Is that bird a conductor or an insulator? Obviously, it's a conductor. It has that full blunt of that 7,200 volts going through it, but it's not grounded. Remember, it only presents a danger when you're on a path to ground. If you could jump 45 feet and hang from an overhead conductor, you would be that bird on a wire. This is something I want you to remember because we're going to talk a little later in this demonstration if you're in a vehicle accident and you have down power lines across your vehicle. If you live in a heavily wooded area, especially after a storm or an outage event, you might see trees laying against overhead power lines. You might think, well, there's an easy path to ground. That line has to be de-energized. I'm going to help SMECO out right now. I'm going to take my chainsaw, cut that tree off of that line. My lights might come back on our house. We are asking you to not help us after outage events. The best way you can help us is to call into our contact center and report your outage. After that, leave it up to our guys to help restore electric power. So they're going to take a tree and bump it into our closest conductor, and you're going to see that that tree, even with it laying against it, will not necessarily kick off that line, but may still be energized. There's two different events I want to talk about with a tree as well. One, it can sizzle and fizzle just like it's doing now and start to catch fire. The smoke should alert you that, hey, something's wrong. You're obviously not going to go up near that tree during that event. But there's another phenomenon as well, where if it's a very healthy tree, it's very big, it's old, it has a huge root ball, you might have that electricity track all the way down the center of that tree into the root ball, deep into the earth. You might be able to go up and touch the outside of that tree and not feel anything, but it's fully energized at that 7,200 volts. Its easiest path to ground is in the center of that tree. So you can't necessarily just go up and do a touch test to a tree, and if you're still alive, you can take it down. Because if you're using your chainsaw, cutting through that tree, and you cut through that center root into the root ball, you just destroyed its easiest path to ground. And now that easiest path to ground is going to go from your chainsaw, through your body, through your feet, into the ground. So even if it's safe and you went up and touched that tree, doesn't necessarily mean that it's going to be de-energized. Alright, next thing we're going to talk about is TV antennas, aluminum ladders, sailboat masts, irrigation pipe, pool skimmers. We're naming every single piece of this material because investigations that the safety department have gone through at SMECO, we found these different types of objects have actually made contact with our overhead lines. So, Doug and Jeremy are going to demonstrate the significant dangers associated with what happens when you have a direct contact with an overhead line. There's this thing people always talk about, the big blue flame. You're about to see that big blue flame. Now Doug can tell you, as he makes that direct contact, remember what it's doing now is a direct path to ground. He actually has to pull with almost all of his might to break that path to ground. The amount of energy created when he does that is so significant, it actually tries to pull the stick back into that line. That arc is created when you're trying to break that path to ground, and electricity is saying, no, 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 I want to remain easy path to ground. Next thing we're going to talk about is unfortunate events when humans make contact with either underground or overhead connections. This hot dog is more symbolic of you than you might like to admit. It's made of water, meat, bones, gristle, fat, muscle, anything you could possibly imagine is in this hot dog. So we're going to put this hot dog into direct contact with that overhead conductor, and you're going to hear a sound that you probably will never forget. It's a sound that I know Doug and Jeremy never want to hear, but most importantly, you're going to see what happens when that big blue flame makes contact with something symbolic of human flesh. The only solace that you can find with an electric shock is that it actually cooks your nerve endings first. So they actually say it's one of the most painless ways to die, but it's not something I would ever want to see or be around. So pay close attention to this hot dog. Don't let this be symbolic of what could happen to you if you come too close while painting your siding or trying to cut down a tree on our lines or any contact with our equipment or lines. SMECO system is now 70% underground, 30% overhead. So this lovely demonstration trailer actually only represents 30% of everything in Charles, PG, Calvert, and St. Mary's County. Everything else could be depicted by those green boxes that you might see in your yard, which we call pad mount transformers, with these elbows inside. These elbows can actually plug into the transformer. It comes through the ground, plugs into the transformer just like that. If there's a significant trauma or event to that pad mount transformer, it could potentially knock this elbow off of its socket. And this center conductor here could remain energized. Meaning if you're a first responder, a fire department, and you see a vehicle that collided with a pad mount transformer, keep in mind that just because it's not smoking or on fire, that pad mount transformer could just be lying, waiting there, waiting for you to spray water onto it or open it up and investigate what's going on. So in any event, whether it's a green box or a pole top transformer or utility lines, make sure SMECO is notified to ensure it's de-energized before you do any first responder actions. Next thing I'm going to talk about is probably the most important. It's the critical events that could potentially save your life if you're ever in that life-threatening situation where you're in a vehicle accident with a utility pole with down power lines. First thing you want to do is just relax. Catch your breath, grab your cell phone, and call 911. They have a direct dial into our operations center, and we can make sure that people are dispatched to you as soon as possible. Breathe, relax, and wait for SMECO to come on scene, de-energize the lines, and tell you that it's safe. Sometimes you don't have that luxury of just time to wait around. Sometimes your car might catch on fire and you have to perform some immediate actions. In that event, what I'm going to ask you to do is put your car into drive or reverse and try to move your entire car off of that line at least 30 feet away. Remember earlier I talked about a bird on a wire? If you have lines across your car, you're essentially that bird on a wire. So you want to take your entire car, drive it away at least 30 feet, and never return under any situation. Lastly, sometimes you might go put it in drive or in reverse, and the car just goes clunk and you're done. The car's on fire, it won't move, you need to do something specifically. That's when you need to go from that bird on a wire to completely isolated from that energized conductor. To do that, try to get a firm footing. If you're in a sedan, try to kick out the back window, get on the trunk. If you're in a pickup truck, kick out the back window, get in the bed. Or at the bare minimum, try to get on the seat of a car with the car doors open. You're going to cross your arms in front of your chest because you don't want to make contact with the car and the ground at the same time. Cross your arms in front of your chest and you're going to leap. Now when you leap, it's not critically important that you have a lot of distance between you and the car. The most important thing is that you have your balance and you have your feet land at the ground at the same time. Because remember I talked earlier about that ripple effect? You don't want to put 1 foot on one ripple, 1 foot on another ripple. You'll essentially bridge that gap between different potentials. What you want to do is land both feet on the ground, maintain your composure. Then you're going to shuffle your feet. This is the only way to avoid that possible step potential. Shuffle your feet without lifting your soles off the ground. Critical distance, 30 feet. Once you're 30 feet away from that, you can start to walk away, call 911 if you haven't done already, but don't go back to that car under any circumstances. First responders do not approach cars with energized conductors on them because they do have that step potential value up to 30 feet. You might just essentially become another victim as well. So just wait for SMECO to ensure that the lines are de-energized. I hope you enjoyed our presentation today. Biggest thing that we do want to ask of you is that if you learned something new today, try to pass it on to friends, families, and neighbors. Because unfortunately, the safety department and other personnel from SMECO can't be everywhere at all times. So please be ambassadors for SMECO and pass on these important critical lessons that might help protect and save somebody's life. Thank you, and please be safe around our electric lines and equipment.